Hello busy people, welcome back to the another video on sorting technique series. Today our sorting technique is bubble sort. Is the simple sorting algorithm that works by repeatedly swapping the adjacent elements if they are in the wrong order. This algorithm is not suitable for large data sets as its average and worst time complexity is quite high. Like quite high means it may be z big of n into n, big of n square. So it is quite not recommendable to use for large data sets. If we discuss about the bubble sort, will demonstrate with an example so that we can simply understand its algorithm and we can code it easily. Let us take example with input n is equals to 4 and array which is unsorted 5 6 1 3. It is unsorted, so we have to sort this array by using bubble sort. So after sorting we'll get 1 3 5 6. We'll do it in n minus 1 iterations. Usually we have seen a selection sort algorithm. Like in selection sort algorithm we have just sort the array in ascending order from index 0 to n minus 1. So in this bubble sort it is quite opposite to the selection sort. In selection sort we have done ascending order sorting. In bubble sort we'll just do descending order sorting, like will come from ending to index 0. So for that I will run a for loop. Let's say I is equals to n minus 1. So I will come from last index n minus 1 to 0 index. In first iteration I will just initialize my I value is equals to n minus 1, I greater than or equals to 0, I minus 1. For that I will run a inner for loop to compare every two elements which are adjacent to each other so that I can sort the n minus 1 index element, so that at n minus 1 index I will get a bigger number, like I will get a large number in the whole array. In the inner for loop will run a j variable. Let's say j is equals to 0 to I minus 1. Initially we have taken I is equals to n minus 1. So in inner for loop I will run from 0 to I minus 1, let's say n minus 2. So I will run a inner for loop from 0 to n minus 2 so that I will compare every two adjacent elements, and if they are greater then I will just swap them. Here 5 comma 6 they are in correct position, so I will move to another adjacent pairs. So 6 comma 1, here 6 comma 1 is not as a condition mentioned, so I will just swap 1 comma 6. So our further array will become 5 1 6 3. So our current index, like j pointer, is at 6. So I will just compare it with j plus 1. So j value is greater than j plus 1, so I will just swap them. So finally after one iteration our array will become 5 1 3 6. So our outer per loop we have taken I is equals to n minus 1. So we have successfully placed the largest element at the index n minus 1. So I will just decrement our outer for loop and I will move to n minus 2. So I will now run from I is equals to n minus 2 to I is equals to n minus 2 to I will run our outer for loop from I is equals to n minus 2 to 0, index 0, and our inner for loop will run from 0 to I minus 2, like 0 to n minus 3, 0 to n minus 3. So again I will compare 5 comma 1, so they are not in correct order, so I will just swap them, 5 to here and 1 to here. So again I will just do iteration from 5 3. So here also j value is greater than j plus 1, so I will just swap it. So after the second iteration our array will become 1 3 5 6. Now we can see we have swapped our n minus 2 indexed element to 5, so it is correct. So again I will move our outer for loop, I will decrement by 1 and I will just move to n minus 3. So I is equals to n minus 3 to 0. So I will just see whether 1 and 3 are placed correctly or not. So by comparing adjacent elements, so it is correct. So I will just move to 0 to 0. So here finally we have sorted our unsorted array. So for this we have used 3 outer for loops, like we have used 3 iterations, n minus 1 iteration, n minus 2 iteration and n minus 3 iterations. After that we have sorted our array successfully. So in this way we can run and we can implement our bubble sort algorithm. Like first we have just run our for loop from n minus 1 to 0 and we have placed our largest element at index n minus 1. Next we have iterated from n minus 2 to 0 and we have placed the second largest element at n minus 2, and finally we have iterated from n minus 3 to 0 and we have placed our third largest element at n minus 3 correctly. So for this we have consumed we have done n minus 1 iterations, and in inner for loop we have done n minus 2 iterations. So for that finally our time complexity is n square. We are using 2 for loops, one in another. So in this way we can solve this bubble sort algorithm. So we'll just try to solve the bubble sort. So here is a simple question to solve bubble sort. So the question states that given an integer n and a list array, sort the array using bubble sort algorithm. Input n is equals to find array 4 1 3 9 7. Here it is not sorted, so we have to sort it. So for that I will just use a for loop in I is equals to, we have already seen that we are moving from last index to 0. So for that first I will initialize our I pointer to n minus 1, I greater than or equals to 0, I minus minus, so that for every iteration I will sort the last index and I will just specify the range of unsorted array, like 0 to n minus 1. In next iteration our unsorted array is 0 to n minus 2. In next iteration our unsorted array is 0 to n minus 3, so that we can finally sort our unsorted array. So for that I have used outer for loop, which is from I is equals to n minus 1 and I greater than or equals to 0, I minus 1 minus. So simultaneously I will implement a inner for loop, which is I is equals to 0, sorry, j is equals to 0 to j less than or equals to I minus 1, which is when we are taking our outer for loop from 0 to n minus 1, we have to move from 0 to n minus 2, so that we can compare last element also. Like let's see, if our array of j value is greater than array of j plus 1, so we are comparing two values. So if it is correct, then we'll just use our temp variable to sort two elements. So array of j, and in an array of j I will just keep my array of j plus 1, and finally in array of j plus 1 value I will just keep my temp value. So in this way I can sort my bubble sort algorithm. So finally I'll just compile it and see whether it is running or not. Yes, it is successful. Let's submit it. Finally we have implemented our bubble sort technique correctly, successfully. So I have already mentioned bubble sort algorithm is not quite recommendable for large data sets, because here we are comparing every two elements in each iteration. Like we are running our outer for loop for n minus 1 iterations, and in inner for loop we are just using n minus 2 iterations. So n minus 1 into n minus 2, approximately we go of n square. So it is quite large. So we are not using these algorithm quite often. In some cases we are just using it. Well, if we go further and we'll explore more sorting algorithms, we can just conclude that maybe some more algorithms are very quite useful. Like let's say merge sort and quick sort. In that they are using n log n time complexity. So quite recommendable. Like n square is quite large than n log n. So we are just recommended to use merge sort, quick sort algorithms rather than bubble sort, selection sort and insertion sort. So here is our cheat code for memorizing sorting techniques. Like let's say SBI MQ. So S stands for selection sort, and B stands for bubble sort, and I stands for insertion sort, and M sort stands for merge sort, and Q stands for quick sort. So thank you.